think I'm recording. So, hello. All right, this is lesson 1 of Unit 2, Polynomials and Operations of Polynomials. All right, so let's get into it. This is your notes packet. This is the first lesson, Polynomials. You guys have probably heard the word polynomials before. It just looks like long expressions, but there are a couple rules in order to make something a polynomial. So in order to be a polynomial, basically the two big things are no radicals and no negative exponents. So for example, this yes one, that is a polynomial because look at the exponents. A 3. Technically this is a 1, and then this is called a constant. So that's a polynomial. It's just a bunch of terms added or subtracted together. The no is a no because there's a radical. Now, remember that radicals could also be written as a fraction exponent. So if you see a radical or a fraction exponent, it's not a polynomial. Or if you see a negative exponent, it's not a polynomial, okay? So like I might give you a problem where it says, multiple choice, select the following, which of the following are polynomials? Select all that apply. And then you would just circle the ones that are polynomials, okay? So the other things we talk about when we introduce polynomials are the degree and the number of terms. So a degree of a term is just the highest exponent on the variable. So in this first example, the degree would be 3, not 4. The 4 is called the coefficient, but the 3 is the exponent, so that's the degree. Now, sometimes we have more than one variable. That is allowed in polynomials, to have more than one variable. And when that happens, what you want to do is add their exponents together to get the degree. So this only happens if you have like an x and a y. They're being multiplied together. We actually are just going to add these together. So this is actually a degree of not 4, but 5. Now, if I give you a whole polynomial and say, what's the degree of the polynomial? It's the highest degree. So look at the problem and figure out which term has the highest degree. That is the degree of the polynomial in general. So here's a polynomial. This degree is 3, but this degree of this term, a term is like separated with a plus and a minus. So these are two terms, but this is one term on its own with a higher degree because you have to add the two exponents together. 6 plus 2 is 8. So this degree is 8, which means the highest degree is 8. So the degree of the polynomial is 8. Something that you should have learned in Algebra 1 was like monomial, binomial, trinomial. Does that sound familiar? So we are going to classify polynomials. It's okay if it doesn't. I'll teach it right now. We are going to classify polynomials. So classifying means like, you know, we classified numbers. So some numbers were irrational. Well, we can classify polynomials by two things, either the degree or the number of terms. So to classify polynomials by the number of terms, we have to count up how many, I call them pieces, but terms are separated with pluses and minuses. So this first one just has one term. Yes, it has 3 letters, but there's no pluses or minuses. Do you guys see that? There's no pluses or minuses, so that's one term. Whereas look at the second one. See how there's 2 pieces separated with a minus? There's 2 terms there. This one has 3 terms. Do we see what terms would be then? Yeah? Okay. So here's the special names. If a polynomial has only one term, the name is a monomial. So usually mono means 1, like mono y mono, 1-on-1. Okay? So monomial is 1 term. Binomial, bi usually means 2, like a bicycle. So this is 2 terms. Then trinomial, tri, like a triangle, usually means 3. So this is 3 terms. Anything with 4 or more terms, we just call generally a polynomial. Poly means many. So poly would mean like many terms. Okay, polynomial. Now technically, some students think like, oh, that's not a polynomial, that's just a monomial. They're all polynomials. But these are more specific because we counted the number of terms. Does that make sense? Okay. Ooh, let's write the degrees. So for the first one, the monomial, the degree would be 1 plus 2 plus 4. So that degree is 7. The degree for the binomial, the highest degree here is 1. It's x to the first. So this degree is 1. And for the trinomial, the highest degree, ooh, careful, it's not this one. The highest degree that I'm seeing is the highest exponent, which is 5. And then the polynomial's degree is also 5, highest exponent. That's a good segue into classifying by degrees. So when we classify by a degree, we're saying what's the degree of the polynomial, and then there's names based on that. And actually, you guys, these are really important, really for the rest of the year. Like when we start doing domain and range, I'm going to say, oh, this is a linear function, so the domain is negative to positive infinity, and so is the range. Or, oh, this is a quadratic, so we know the domain is negative to positive infinity, but the range is going to be bottoms up. All of that might sound like a different language to you right now, but understanding what the functions are is actually really important, and that's by degrees. So if we have a polynomial with a degree of 1, x to the first, okay, we call that linear. And the reason it's called linear is because the graph of a function with a degree of 1 is literally a line. Okay, a polynomial with a degree 2 is called a quadratic. We're going to be factoring quadratics this week, x to the second power. That graph is a parabola. You don't have to know the shapes of the graphs for this unit, but you do need to know them in a later unit. So I'm going to draw them now since we're talking about it. Cubics, degree 3 is a cubic function or a cubic polynomial. And we will be graphing cubics this year. They look kind of like a squiggly line, like two parabolas almost, one going up, one going down. And then the fourth degree is called a quartic. And we will be graphing quartics this year too. They look like a W. You do not need to know those shapes. That was just kind of a side note that you will need to know later, not this unit. What you do need to know this unit is if it has a degree of 1, it's going to be a linear polynomial. Degree 2 is quadratic, degree 3 is cubic, and degree 4 is quartic. So before we move on to the operations, let me give you guys a quick example here. If I had x to the fourth plus 2x squared minus 1, I would say that this is both quartic and a trinomial. It's quartic because the highest degree is the number 4, and it's a trinomial because there's 1, 2, 3 terms. So all we have to do today for the rest of this lesson is operations. So operations in math are like adding, subtracting, multiplying, dividing. So we are going to add polynomials, we are going to subtract polynomials, and today we're going to stop after we multiply. Tomorrow we'll do the division. You did this in Algebra 1, but you know, in Algebra 2 we definitely like step it up. So it's going to involve distributing and combining like terms when we're adding and subtracting. But look at me when I say this. The biggest thing I need you guys to do is look at the problem and ask yourself what is happening between the parentheses. If it's a plus sign in between the parentheses, you should not be foiling. We do have to distribute in number 1, not FOIL. This is not a multiplication problem. I'm simply going to distribute the 3 and then combine like terms. If there is a minus sign in between the parentheses, you will have to distribute the negative, but then you're just combining. You only FOIL if there is nothing in between the parentheses. That's when it's multiply. You guys good with that? All right, number 1. Let's do it. Distribute the 3. Okay, 2 times 3 is 6. Plus 15x squared. There is nothing to distribute to the second set of parentheses. Oh, wait, you still need the notes, don't you?
Yeah.
Come on up. So polite. Drop down. And now you guys combine like terms. I'm so sorry. You're so polite, not even saying anything. Oh my gosh. Okay, that's a long code. Can you open Schoology? Here we go. I got you. I'm gonna do it for you. Okay. Did everything I just say make sense?
Yeah.
And you've seen it already?
Yeah.
Okay. Is my teaching okay?
Mm-hmm.
Okay. So don't feel like you don't have to fill in the notes that you just missed because
Right.
that was my fault. However, you can start with this problem.
Alright.
Okay? I'm so sorry about that. Okay, you can download that and then, there you go. All right. All right, sorry about that break. My B. All right, so final answer should be 6x to the third. 15 and 5. You can combine the x squareds. So you should get a what? 20x squared. And then a minus 6x and a plus 10. So do you guys see how I switched around the order so that it went from the highest degree to the lowest degree? Do you guys see that? That's how I want your answers to be written, always. Highest degree. This last number is called a constant. That should always go last. Questions? Let's do number 2. Okay, there is a minus sign in between. I am going to have to distribute that negative. I'm going to distribute this 3 first. So that's a 21x minus 6x squared. Now, when I distribute the 4, I need to distribute the negative with it, and that is taking care of the subtraction. So I am going to get a negative 80, a minus 12x, and a plus 24x squared. And now I just combine like terms. So the highest degree is the 2. So negative 6 and 24 gives me that 18x squared. So 21 minus 12 is giving me that 9x, and then minus 80. The next problem has nothing in between the parentheses, which means I have to multiply, and it's a binomial times a binomial, so I will be doing the FOIL method. We did a little bit of FOIL in the last unit, so you guys kind of might remember, but I will remind you. So FOIL stands for first, then outside or outer, then inner, and then last. That's what that FOIL like acronym means. So I am going to be doing the first times the first, okay? So 4x squared times 2x. 4 times 2 is 8, and when you multiply, you do change the degree. So x squared times x is x to the third. 4x squared times negative 1, these are the outers, the 2 outside pieces. That's going to be a minus 4x squared. Now the inners, or the insides, 5x times 2x is 10x squared. X times x gives me that x squared. And then 5x times negative 1 is minus 5x. So I do have an 8x to the third. The x squareds in this problem do combine. So that's going to be a positive 6x squared minus 5x. You do not need to factor out like a GCF or try to factor your answer. If you do, you'll just potentially end up back with the original problem. So we are going to move on to factoring next week, but today you're just foiling and stopping. Okay, now in Algebra 1, you should have seen a binomial times a trinomial, but it might have been like the harder problems. I'm going to show you my strategy when I multiply a binomial times a trinomial. So for the binomial, I always like that one on the left. So I'm going to start with the first term of the binomial, and I'm going to distribute it to the trinomial. So this is a version of FOIL. It's just looking a little different because we're not doing a binomial times a binomial. So 6x to the second times negative 2x to the second is negative 12x to the fourth. Are you guys comfortable with how I'm adding the exponents when I'm doing this? Because when I multiply the x's together, I have to add their exponents. Then I'm going to do 6x squared times negative 3x. So that's a minus 18x to the third. And finally, 6x squared times negative 10, or I'm sorry, I said that wrong. 6x squared times 10 is 60x squared. Okay. Negative 3 times negative 2 is going to be a positive 6 x to the second. Now, let me say this because I kind of left this part out. The next step is to take the second term of the binomial and now distribute that to the trinomial. So I'm going to take this negative 3 and I'm going to put it to all three of the trinomials terms. Okay, so negative 3 times negative 2 is 6x squared. Now, this is kind of weird, but this is how I do my work. I actually line up the terms vertically so I can see really easily what's going to combine, if that makes sense. And so then I'm going to do negative 3 times negative 3x. That's a positive 9x, which doesn't line up with anything. And negative 3 times 10 will be a minus 30, also doesn't line up. So the only ones that line up are the x squareds. Everything else just stays on its own for my final answer of negative 12x to the fourth minus 18x to the third plus 66x squared plus 9x minus 30. A long answer. Okay. What are your questions for me? We good? Is this somewhat review-ish? Maybe a little bit. Algebra 2 is always going to go a little bit harder than Algebra 1, but hopefully it's stuff you guys have seen before. Now, I don't think we need to necessarily do all of these next problems, but all of these problems have like somewhat of a pattern, okay? So something, and honestly, look at me when I say this. If I were you, I wouldn't even memorize these patterns. Honestly, I would just FOIL and see what happens. But just be mindful, if you do have the same parentheses, but one has a plus and one has a minus, things should cancel. That's the bottom line with this special product. At the end of the day, I would just FOIL and see what happens because it's one less thing for you guys to have to memorize. Does that make sense? And we are going to be memorizing things in this unit. Like when we factor, we are going to be doing all the normal factoring, but we are going to add in factoring sum and difference of cubes, and that's a formula you have to memorize. So I would say don't work on memorizing for this section. Just FOIL and see what happens, all right? So 4x times 4x is a 16x squared. This is a FOIL problem. 4x times negative 2y is minus 8xy. 2y times 4x is a positive 8xy. You could say yx or xy because of the commutative property. Are you guys comfortable with that? I always like to keep it in alpha order, so I always write xy, okay? And then 2 times 2 gives me 4, but careful, it's positive times negative. So minus 4, y times y will give me that y squared. But like I said, things should cancel if it's a plus and a minus and exactly the same otherwise. So your final answer here is 16x squared minus 4y squared. Questions so far? I think I'd like to do 2 more examples with you and call it a day. How are you guys feeling about that? Okay? All right. We're going to do the next problem. Hold on, I'm just looking up your first mini quiz. Okay. Yeah. All right, this one. Hey, careful. Careful. Because some people are going to want to just square the 6x and square the 4, which is not what we do. Okay? The reason we cannot do that, we did do that in the last unit where we just squared everything in the parentheses. The difference is this. Those problems, none of them had a plus sign in the parentheses or a minus sign in the parentheses. It was just a bunch of letters next to each other. That's when you can distribute the power. If there is a plus sign or a minus sign, you cannot distribute the power. So instead, think about what it means to square. It means to multiply it by itself. So what you're going to do is write this out twice and then FOIL. Okay, 6 times 6 is going to give me a 36x squared plus 24x, and then plus 24x again. Now, things don't cancel because this one has the same sign twice. 4 times 4 gives me that 16. Combine like terms. 36x squared plus 48x plus 16 is my answer. Bless you. We'll do one more. So I'm crossing off 8 and 9 because neither of those are on your mini quiz. I can double check the test. I actually do not think they're on the test either. So I'm not gonna waste your time. Let's see. Just checking. Yep. Okay, not on the test. So we're gonna just get rid of those. Let's finish though. This one could be on your test, or something like it. So we are going to do this one. Also, this is being squared. There is a minus sign, so you write it out twice. Exactly the same twice. You don't change anything. And then we FOIL. So 3x squared times 3x squared is 9x to the 4th. Okay, so 3x squared times y, it's going to be a minus 3x squared y. You literally just put the letters next to each other. And then this one is another minus. You could do 3yx squared. I like to keep it in the same order, x squared y. And then negative times negative will be a positive. Y times y is y squared. Final answer, 9x to the 4th minus 6x squared y plus y squared. Okay. What do we think? Is that okay? It's like algebra 1.5. You know what I mean? Like this is all stuff we saw in algebra 1. However, in algebra 2, of course, we're going to add in extra variables and just make the problem slightly harder. But it should be kind of a review of stuff you've seen before, right? All right. My summary says this. Polynomials, these are the big takeaways from today. Polynomials have no radicals or negative exponents. You need to know how to classify the polynomials. So you need to know monomial, binomial, trinomial, linear, quadratic, cubic, quartic. To add, we combine like terms. To subtract, we distribute the negative, then combine like terms. And to multiply, we're going to use that FOIL method. Those are the major takeaways today. Any questions for me? Okay, so homework is worksheet 1. Let me do this. Let me pull up our Schoology. Homework is worksheet 1A. I will post the optional Delta Math. My guess is Y'all don't probably want to do it, but I can always post it if you need extra practice. Let's take a look at that worksheet one. Let me make sure it's in a separate packet. So you have to download the worksheet packet. And let's see. Oh, it's worksheet 1A. Sorry, just worksheet 1A. It's only 10 problems. And there's like 15 minutes left of class, and I'll give you guys the rest of the time to do this work. Okay? Sound good? Okay.